All right, cool to see you again. Some of the faces were in the previous session as well, so nice that you're staying here. Apparently this is interesting and you're learning things. But for the ones who are new in this room, I'm going to talk about protecting your code with GitHub security features. My name is Rob. I'm coming from a DevOps background. I call myself a consultant there at Xpirit from the Netherlands. And I do anything there for my customer that regards DevOps. And for the last year or so, I've been focusing, now I think it's 2 years already, on GitHub stuff. And GitHub has really awesome security features available for you if you have an open source repository for free. So this for me is a no-brainer of using GitHub. My modus operandi is I always try to use an open source library first, or create one, and then bring that back to my customer, for example, and implement things there. That way we can all learn and start to improve on this. I've been using these features for a long time, also a GitHub trainer, training GitHub customers for that as well. But then I'm mostly using it. I'm not so much here to sell you all these features, but I think they're awesome. So you should at least be aware of them and maybe start using them as well. My Twitter handle is in the lower left-hand side, so you can always reach out to me with questions. My blog is in there as well, so usually when I cannot find something, that's usually my trigger point or starting to create a blog post for that. So there's lots of stuff available on how to use GitHub on my blog as well. So if you want to learn more, go there and read some extra things. In my previous session, I said it already, this is my first conference in 2.5 years, so I'm very happy that I can even be here, even though it's pretty exciting to be here and stressful. At Xpirit, we have a slogan that says, go out and do epic shit. It's up to you to define what epic shit is. For some people, it's standing on a podium at a conference, and I'm here, even though this is super scary. And anytime you do that, we try to bring back our knowledge to either the community, our customer, the people that we work with, for example. And for that, I've got 3 t-shirts still here to give away, if you want one. I didn't bring them for nothing. I only have XL and XXL available, but they have our cool Do Epic Shit logo on it. You can have one, sure. Do you need extra large or extra large? For you, I'll make an exception. The rest needs to make a picture of me and tweet it to me. You still can't do that?
Who are you on Twitter?
At RobBos81, but it's in the slides. You want a shirt? Yes, thank you. And this is some of the fun things that we can do as Xpirit consultants as well. I'm here to tell you about all of those security features. Who here is already using GitHub? Doing things with that? Awesome. And from that, we can continue then. Going through all of these topics and share a little bit of what you need to know about these things. And you can start using them already today on your open source repositories. Why are we doing this? Well, this is of course goes without saying. We're at a security conference. We're talking about attack vectors. And anything we have inside of our code, for example, is an attack vector. Any shell script you use to make your code is an attack vector. Anything you do to make your code into an artifact and deploy it somewhere, that's an attack vector. So we all need to be aware as an industry what we're doing, why we're doing these things, and we try to protect ourselves as much as we can. And for me, it starts with who the hell can push your code? In GitHub, you have that available in the UI. And you can go into settings, for example, and find out who has access to this repository and which type of access do they have. In this case, that's a colleague of mine helping me out with some open source stuff. And from there, we start thinking, who the hell can push code? And by default, we give our users, at least inside of a company, give them write access, for example, they can push code into a repository. Now your CI system can pick it up, do things for you. Indirectly, on public repositories, anybody can there fork your repository and then send in a pull request. And if you say, hey, this is awesome, this is just a one-line change, I'm accepting that pull request, you could be screwed because you're pulling in a malicious dependency all of a sudden. So it's up to you to make sure that you verify what is happening, who has access, and it starts by figuring out who actually has access. And on the GitHub side, we have a couple of ways to push code. It's not only by the normal SSH way or HTTPS way. You can also use things like deploy keys. You can install a deploy key onto a server, give that authorization to one repository, and now that server can push code into your repository, all by itself without you doing things. So you need to be very aware of what you're doing there. And it all starts with you as a GitHub user. Who here has set up GitHub two-factor authentication on their account? All right, that's good to see, at least at a security conference. So at least you're aware of that. Well, the nice thing is, This is how you push code into your repository. You say, I'm a specific user, here's my email address, and with that, you can start pushing the code. When you do a git push, you push that to your remote on GitHub, and now it's stored there as well. This information is used to match the user in the UI. It's attached to your commit. It says this is the user that committed this code, and you can use that. This is the part that GitHub uses to verify or show you which user made that commit. It's not checking your authentication method. It's only using the email address that is there. So your two-factor authentication doesn't really have anything to do for what ends up in your repository. It is used for authenticating that push, but whatever is in there gets pushed. And you see that information in the UI. On the left-hand side, you see all the users. They say these persons have committed. All of that matching is done based on the email address. If I make a commit and I tamper with that email address and I override it with something else, it's now inside of your code. And then here it shows that person made that commit. So why is that so bad? I can do this for you. If I can get into your CI system, your local system, I can create a script and start making commits for you. That's usually what I do when I give trainings. I create a script that fills up a repository and automate this for you. And the authentication method that I use to push that code is different from the users that GitHub shows you in the UI. By default, as I said, you do a git commit there and you push that, and I can do that for you. Doesn't matter which authentication method you use there. And I said, who is using two-factor authentication? That is just the communication part for sending in the git push, for example. Who here is already using commit signing? 2 hands. Yeah, I would have expected it from you, Scott, but the rest is a bit, I would have expected more. With commit signing, you really sign your commit locally before you start pushing it against a remote repository. So that is an cryptographic way of saying this is my private key. I will sign my commit with that private key. GitHub has the public version of my key, and with that it can do real verification. Did that commit come from somebody who can sign with this key? You do that by adding a GPG key on your machine, have a whole setup for that, and match that public key in the, on the other side on github.com. You then need to start signing your commits with a capital S, saying this commit is now signed by my GPG key. Locally, your process will pick that up, saying, hey, this commit is being signed, downloads or uses your local GPG key, attach that to the commit, and when you do a git push, that information gets also sent into the remote. And GitHub can then do some verification and show you that this commit, the signature comes from this specific person. Now you've got another extra layer of security on top of that. You can also configure that on the local side, saying I always want to sign with my GPG key. That makes it even more secure, and now you don't need to think about it, you can just start signing it. And I've got a small demonstration for that I actually forgot to prepare, my apologies. Just to indicate how this works, then I need to tell it to find my screen here. I have set up git commit signing on everything locally as well. Let's say I make a change here to my README file. I just add a new line just for to have something. I'll show that in my editor, just making sure that the service is actually running because I haven't checked that today. On Windows, you have something like Cleopatra where you can create your own GPG key locally, store that, and this is the service that then hooks into my Git setup locally. That will say, hey, you're committing now something, so I want you to sign it as well. And I know that I often need to wake this up the first time. You've got other ways for this to do this on Linux as well, for example. Lots of cool stuff that you can do there. You can even get a physical key, install the GPG key on that key, and now somebody needs to bring in that key, shove it in the machine and saying, this is really from me. All building up more and more trust. add them both. Well, now when I do a git commit, my machine should pop up with a extra setting there. Usually this is indeed faster. Hoping that this doesn't fail. It's always nice for live demos, of course. It should give me a pop-up and say, hey, somebody's trying to use your GPG key, and I have made my setup locally that I need to include a password, otherwise you cannot sign it with the GPG key. You can still start using the GPG key, but miss that you set up an extra way of authenticating. Then it can still automate your commits for you. This seems to be failing, but I came prepared, and I've got an example here. It's just a pop-up on Windows that says, hey, please give me your password. But with this, now I have something that I have, my GPG key, and something that I know, my password. And I use that to sign my commits with. And then, instead of only showing that on the left-hand side, I've matched this user to this email address that people said were attached to that commit. I get a little bit more information, because with that, I get actual verification statuses. And these verification statuses go back to your signed commits. They search for that, match that to your public GPG part that they have. And with that, they can tell the users, this commit has been verified or not. And this is shown everywhere in the UI. So if you're in a pull request, you see the commits. It's shown that this commit was verified by using a GPG key. And you can greatly improve the security of your repository with that. You can even enable vigilant mode, that's currently in beta, that says, I want any time that you show my name on a commit, I want you to show that to the other user if that commit was actually from me by matching my GPG key. So anytime somebody uses my email address, this is the starting point, they at least show in the UI, well, they say it has been created with this email address, but the GPG key doesn't match. And now the other party can then make a decision if they want to include that, for example. This is a starting point in improving the setup there. It has 3 statuses when you enable vigilant mode, verified, partially unverified, and unverified, and it comes from these checks. If there's no commit signature, it's unverified. If the commit is signed, but it couldn't verify the signature because the public part was missing, it's partially verified. And if the commit doesn't match the author, it will also say it's partially verified. So you get a little bit more information on who actually made those commits. And even when it's unverified, if you hover over that, it will tell you why it isn't verified. So in this case, the commit wasn't signed, and I have enabled vigilant mode, so it makes it very visible that this commit came from me without me using my GPG key to tell GitHub saying, this is really coming from me. So it's a good starting point. Yes, you can then even include that in your branch protection rules, saying I want always to have a merge pull request coming, for example, before merging. But you can also say I only want to allow signed commits coming into my repository. This is of course a way to force your users to start these things. But with this you can really make your code base way more secure. Because as I said, I can create your commits for you in a shell script doing that for you. And that's really scary, because if I use an NPM package to pick up on NPM, I can create a script there that creates a couple of commits for you. And now you're unwillingly pushing that into your Git repository. So that's a step that you can make to improve the way of working on the GitHub side. And depending on which source control system you use, this might already be available. I think it's available in GitLab. And Azure DevOps currently doesn't support signed commits, for example. So be aware, in GitHub we have this available. This does give a little bit of extra impact for your users. They need to install those tools, but we're trying to make us as an industry more mature and more secure. And there are some steps in the automation pipelines as well. It used to be that Dependabot didn't sign those commits automatically. Now they do, luckily. So you can see that this is really coming from Dependabot with their GPG key that they use. For GitHub apps, you need to do a little bit more work. And if, God forbid, you're still using personal access tokens to do things against GitHub, except for your own authentication, you need to sign those commits as well. Install a GPG key on the machine that you're running this with, for example, and then use that key to sign your commits with. In CodeSpaces, there is a setting that you can set up on your user account whenever you use a CodeSpace. Who's using CodeSpaces here? Who knows about that? No one. 1, 2. With CodeSpaces, you get compute in the cloud. And you can hook into that compute with a web browser coming from VS Code. And it's like you're using the compute locally, but you're doing everything inside of a browser. So with CodeSpaces, I can give you a virtual machine setup in the cloud, managed by, in this case, GitHub, with a set of resources, and you don't need to install anything anymore locally. I can pre-provision that whole thing, installing the tools that you need there, and we have a real cool, workable setup. And the only thing you have running locally is a web browser. So with that, we can improve even more. If you use those things, then I think by default it's disabled right now, but you can enable the usage of GPG keys on those repositories as well. GitHub can create that for you at the background, and when you make a commit, those will be signed as well because they are tied to your user account now. So it's very helpful to improve that as well. That was commit signing. So that could be your first step to start improving the way you work against your repository. The email setup with just verifying that this commit comes from this person based on a text annotation on a commit is not good enough in my opinion. We should try to make that a little bit more secure. Next up is Dependabot. With Dependabot, this comes from software composition analysis. It tries to figure out what components are you using inside of your software. Which packages are you pulling in and which versions are you doing that with. For that, Dependabot is available for a while already. You can use that for free on your public repositories. And with this, the starting point is figuring out what the hell are we using? What type of packages are we using? What for? Which versions are we using there? And then you start to learn on what can you do more with Dependabot and how can you do that. And I've got some samples in the demos as well. It starts with configuration. You can enable Dependabot and then it will start to do software composition analysis for you. So it tries to figure out which types of packages you use in your application. And stores that in a database with your repository, and then you can go and look up to that. With this configuration file, it needs to be stored in the .github folder. It's one of those magic files, so I've got a blog post detailing all of the magic files that are available in GitHub. If you use GitHub, then you know there's a lot of incantations that you can do, and if you do that right, then it does something for you. That's something similar to Dependabot. By adding this file, it needs to have that specific name indeed. You can start using multiple ecosystems. You can tell Dependabot I'm using NPM. In the root folder, you can start searching for the manifest files for NPM, in this case package.json and a package log file. And you can inject an interval in the times you want to do that. Dependabot has the database in the background for all the packages and the versions that you use. And in this schedule, they will match that against the database that they have. Saying, hey, you're now using version 1.2.5 of this application. We see in our database that 1.2.6 is available. Here you go, developer, here's a pull request, and you can start updating it. That's a one-line change that says I'm updating that version from 0.2.5 to 0.2.6. Super easy. And what we see that we can bring back being up to date with the latest versions, bring back having vulnerabilities in there and fixing them by upgrading them to a later version. We can bring that down into 2 weeks for a developer to fix that. Usually what you see that this takes years for somebody to start thinking, hey, maybe we should update our dependencies. Well, we haven't done that for so long, everything will break. And we're scared to do that. With Dependabot, you do this every week. And hopefully you have a good CI/CD setup that actually verifies that your stuff still works. And then this makes it a lot easier to stay up to date with the latest versions. Yeah, this needs to be on the default branch indeed. And I've got an example in here of the things that you can expect from Dependabot. In this case, this is a pull request that Dependabot generated. Oh, happily from 1.2.5 to 6. This is a package that I use from NPM, I think, coming in. And this is running on that schedule that I have. It even found out I am using that specific version of this package that I use, and it has a security vulnerability in it. So it immediately tells me, hey, you should probably want to update this to the latest version. You can learn more about that security vulnerability, but I'll come back to that later. Dependabot focuses initially on keeping your dependencies up to date. And in this case, the pull request is just updating that version from 1.2.5 to 1.2.6. Automatically, I don't have to do anything except for look at the pull request, see if I want to update it, and this is really easy now for me to update. It knows that this comes from a public repository. You can see that on the lower left-hand side. It's even a github.com repository, so you can go to the repository and see what is happening there. Get a network overview, who's contributing code, how active is this being used, why are they even releasing a newer version, for example. And since Dependabot runs on GitHub, they have that information available already, so you can get even an overview of all the incoming commits in this version bump. So you can track and see what actually is coming in from those versions. You can even go to the compare view and then there learn all the changes that were made, those are those commits, and really go through the source code and figure out what are they changing. Because you're pulling in a newer version and you want to see the delta that is in there, making sure that they're not all of a sudden doing something weird in your code. So with Dependabot you have that full overview and insight. It will even tell you a compatibility estimation because this is GitHub. They have the information of all the pipelines that run. Most of the applications here or packages run it in GitHub Actions. And Dependabot can see if we bump this specific version for this package, how many times after that does the pipeline fail. And we can give you a confidentiality score then. This is how confident are that this will be compatible with your system. All that information you can use to make a decision, do I want to update this version or not? And that makes it really easy for us to use. Available out of the box on open source repositories. It will be a waste if you don't start using that. This were some screenshots in case GitHub failed again. We saw a lot of failures in the last 2 weeks. Yeah, I went over the change log, the commits are there as well, and the compatibility score. And if we then open those up, you've seen the commit list already. If they use a change log in their release, you can see that as well. And you can even go back to the change log and really see all the release binaries that they have attached, for example. So all the information that you need to see if this is workable or not is available as well. Yeah, I show that. Interestingly enough, in the pull request that they send in, you can talk to Dependabot and give some parameters, tell it, hey, I do want to ignore this specific major version because there are code changes in there and it will break my code. You can also do that with some configuration. So the pull request that is created is also an opportunity to tell Dependabot a little bit more on what to do and why you want to do things there. Doing that in your configuration file, this is the Dependabot config again, you can say for this specific dependency, I want to ignore version 4x and 5x. Because of reasons, but you have that opportunity to make that visible inside of the setup. This will tell Dependabot to not create pull requests for that specific version. So if you have reasons why you cannot migrate to the latest version, you can still let Dependabot run for minor versions, so everything on the X part there, and let that update for you still. You can also say, for this specific dependency, I never want to include updates. A bit strange, but you have the opportunity. It's your foot that you're trying to see if you can shoot that. So be aware of that. But you have that configuration ability in Dependabot as well. And then you can also say, for this one, I want to skip all the patch updates. I did miss indeed the part about semantic versioning. Who here uses semantic versioning and knows about it? Just a couple of people. With semantic versioning, you have those versions, 1.2.6. That 6 is the patch version. And as long as the versions in front of it stay the same, it should always work because it's always backwards compatible with the previous version. If there are breaking changes, then the major version, the first number, changes. So as long as that stays a 1, it should only be additive, extra features or extra functionality in the library that you use. And we use this mechanism to tell Dependabot, for example, hey, I only want to use patch versions. And I want my developers to make a choice when we include a minor version. That was Dependabot in a highlight. If you have any questions in between, just raise your hand and then we can try to address them. Go ahead, sir.
Can you speak about Dependabot and its ability to find dependencies?
I should have done that in the demo indeed. I will do that shortly. I missed indeed, maybe I have it in this part. Let's see. If you know from Dependabot what types of dependencies you're using in your setup, then it can also match them against a vulnerability database. It has the database. There's a NIST database that we have available as well that says this specific version of that specific package has a vulnerability in it. Learn more about these vulnerabilities, for example. Dependabot has that insight into that database as well. And from that, it can send you in extra pull requests as well, saying, hey, you need to fix this security alert that we have. There's a vulnerability in here. I get these things weekly now, because that is where we are as an industry. People are finding more and more vulnerabilities in packages. And Dependabot helps you with that and sends in a pull request. Hi alert, you need to fix this, something is happening there. And we can send those alerts either to your repository, to the owner, but also to specific rules. If you have a CISO inside of your environment, for example, we can send that person with the right role also alerts from that. You need to enable that, but it is again for free on public repositories. You need to enable that on your repository. You can also do that at the organization level and just blanketly say anything inside of my organization, I want this enabled, which usually is a good thing to do. You can also enable the dependency graph, and this is where Dependabot starts to run the whole software composition analysis scan. And I think I have a demo for that ready. Because in this repository, I've just forked this somewhere. This is a Node application. And then here I can show you how it does software composition analysis. If you go into Insights and Dependency Graph, this is also available on any public repository. And this failed earlier today as well, so they have some weird things in here. And then I switched back to a different repository and there it worked. Really strange. This should work here as well then. Darn it. Demo gods. One more try. And then I need to see if I got screenshots for this as well. This one works. Same functionality. If you have a public repository and software composition is enabled, you get a dependency graph. This is where Dependabot starts. It searches for that ecosystem that you have for manifest files. And for npm, this is a package.json or the log file, for example. And then there, this is in a minimus library, so it's only short. This uses 3 different libraries to build on top of and do its work. And this package, minimist, uses those 3 versions in the right-hand side to do its work. But this dependency, this is a direct dependency, this dependency uses dependencies. And this is what the question was about, transient dependencies we call these. The dependencies are dependencies. And this is really turtles all the way down because browserify has dependencies on, for example, Backbone, which has dependencies, This is really turtles all the way down. And if anywhere in the supply chain is a vulnerability, everything on top of it is vulnerable as well. Might be not specifically in your code. It might not be something that can be reached from your code because you're not using that functionality. Nevertheless, it could be an attack vector and we need to try to protect ourselves from that. So this is where Dependabot starts, figuring out from the manifest files, and we have support for 7 or 8 ecosystems there. Finding out what those dependencies are and then matching them against the database of versions, so it can send in a bump pull request to update to the latest version, but also for security alerts, matching that against the security database. This goes both ways. These are the dependencies of our package, so these are the things that Minimist is using, but these are all the things that are dependent on Minimist. 14 million repositories are using Minimist. So if there's a vulnerability in one of those 3 direct dependencies that Minimist has, then these 14 million repositories might also be screwed. This is what we talk about, the attack vectors and the size that we have as an industry that we're trying to improve. So those 14 million repositories apparently spit out 30,500 packages that go back into the ecosystem that people can use on. So the scope of this is quite large. Let's see, I was going on alerts, and then my demo failed and I lost track. I probably have one in here that indeed says, Dependabot has found a security vulnerability. Big alert, this one is critical, please go fix it. This is what we can give back to ourselves and our developers in our organization. Available because we enabled Dependabot, and it is scanning our dependencies and matching that against the database. You can learn more about that vulnerability that it found. We saw that there was a pull request attached for that. Let's clear this one so I have a example here, and doesn't matter, there are 50 of them, so I can pick one. And Dependabot starts to give you more information. Where is this thing coming from? Anything that is lower than version 1.3 is affected. 1.3.0 was made with the fix in that, so you can try to improve that. Usually what we see is that vulnerability researchers do the responsible disclosure, so they go first to the library author saying, you have an issue, can we please fix it? Then the fix becomes available, and then we get a pull request with a warning from Dependabot. For free, available on your public repositories. So a no-brainer to start using it. You can learn from here more about the specific vulnerability in here, what it is. You can see that it matches back to a common weakness enumeration database. So there's a database on Mitra in this case, where you can learn more of what type of attack vector is this using. Learn more information, and it's very interesting for us as developers to figure out how we can try to protect ourselves. Learn more on how you can hack yourself, for example, and improve that whole stance inside of your team. We as developers have the responsibility to try to make this more secure. We cannot get away with we're just using a package from a package library anymore. You can learn more about why it got this severity score. In this case, this was high. That was made on these common vulnerability scoring matrix, the base metrics that are there, figuring out why we give it a specific score. In this case, a 7.5. It's based from 0 to 10. So this comes from the scoring system. The attack vectors here is just coming from the network. So I don't need to be on your machine. I can go through the network. That already gives us a higher score. I don't need any privileges to misuse this attack, for example. There's no user interaction for that. And with that, we build up that score, indicating to you this is a high vulnerability in this case. So all that stuff we can learn from, and it's available on your repositories. There's even a link back to the GitHub security advisory database. It has a specific ID, and then you can even go to that advisory database and learn more on the reasons why this is here. This is coming from NPM. Also part of GitHub these days. So they have that visibility in there, and they can give you that information. They even indicate that this has been reviewed by the GitHub security team. There's a team of researchers working now around the clock, verifying all these security alerts. Saying, hey, are these actually reachable? What does the maintainer say? We see different systems that only say, well, it is in the Mitra database, so it's probably vulnerable. GitHub goes back to the maintainers and has that discussion. Is it really a vulnerability, or are you disputing this with a good reason? And they can include that inside of their own database. This GitHub advisory database is open source, so you can contribute to that yourself as well. They've released that 1 or 2 months ago, where they invite the security community to share those insights back. And then here you've got even a tied back to all of my Dependabot alerts for this specific package. So I've got 184 repositories that I'm part of that have a dependency on this package. So if this is a high vulnerability, I can see that within my organization, and I should probably do something with that. Even better, if I go back into a demo training account that we have from Microsoft. In this case, we're teaching Microsoft people how to use GitHub. It's wonderful that I can get to do that in my job. Under security, they bring you a single pane of glass, telling you you've got all of these vulnerabilities, single pane of glass for my entire organization. We've got 800 repositories at risk. Some of these that we don't even know about right now. We've got 8,000 Dependabot alerts on all the training repositories that we have. You have that available inside of GitHub. This is officially part of a paid feature. But you can bring that into your source ecosystem, your source control management system that is GitHub. So those functionalities are available as well. Yes, we went to the database. In this case, Dependabot even indicates if they cannot do this, they indicate if it's a transient dependency or not. If it's a direct dependency, they can send in a pull request, for example. If it's transient, they often cannot, depending on the ecosystem that you use. And then they give some more guidance on what you can try to do there. For example, check the logs to indicate what happened and why. All right, so that's Dependabot alerts. That is getting the alerts saying, hey, something has affected your dependencies. If you want to enable updates, you get pull requests for them as well. But those are features that you need to enable in your repository. And I think that's even the next part that I had prepared. Yes, enabling Dependabot security alerts. updates, the alerts will generate the alert, and that alert is visible in the UI. If you use the GitHub CLI, it's available there as well. You can even include it in your Git client. When you do a Git push, it will be shown in the logs there as well. So we try as much as we can to give that back to the developers so they can act on this and improve things there. Yeah, I already showed this part. We went through that as well. Still screenshots in case something was borking. One cool new addition that they have, or new, was one of the later things, and they're really going all out, it seems now, is secret scanning as well. And why do we do this? Well, you've seen this perhaps. Secrets have a huge risk there. If you commit it into your repository, especially if it's a public repository, and you commit a token to deploy into your cloud environment, for example, you could be toast. We have malicious attackers who are actively watching GitHub repositories for these things, seeing if you have an OpenS3 bucket, for example, and then start misusing that. I've even once got an email from a company that said, we see that you posted a public key into your repository. With our software, this would not have happened. Please pay us. They were actively mining this information in GitHub repositories. We have, 73 million users on GitHub right now, so there's a large opportunity for attackers to learn something that shouldn't be there. So secret scanning is now enabled on public repositories by default. You cannot even disable it. GitHub has said we want to try to protect the community. If it's on an open source repository, this is enabled already. Now, there are over 50 partners right now, coming from the major cloud providers, for example. Discord is there. Anything that has an API token that they, for example, share, they can become a scanning partner of GitHub and start improving our ecosystem there. GitHub itself is a scanning partner together with NPM. They've made some improvements to make sure that we can even recognize the secrets, saying, hey, this is a GitHub token, for example, and we can, with more confidentiality, confidence, say that this is one of those access tokens, and then give that back to you as the user without a lot of, what is it? Darn it. Maybe I got it in here. This is the way that it works currently. When you as a user make some changes locally and you commit that back, you commit that to your repository, and then you push that data into GitHub, a background process will run that runs regular expression patterns on those secrets. And this is why it's so important that we can recognize those secrets. Usually what everybody did was, here's a 16 character token, and that is your API token. And from that we had some fuzziness because it was hard to tell where it came from. But you could still try to log into that through different cloud environments, for example. That is why GitHub is now prefixing their personal access token with GHP, GitHub Personal Access Token, and then an underscore. Then they have higher confidence that they can say this is a GitHub Personal Access Token. They run those patterns. If they find something, they send a match to the verification endpoint of that vendor saying, hey, we found something, can you please verify if this is a live active secret? And then depending on the partner, they can check if it's a real match, and then they can make a decision. The GitHub Personal Access Token, if that is stored inside of a public repository, they immediately revoke that secret and send you a notification saying, hey, we found an active access token in your repository. You should not do that, and we have already revoked it for you, because the opportunity to misuse that is, of course, huge. If you get my personal access token, then you got access to 12 of my organizations, even from a customer, for example. That is why I also say don't use personal access tokens there, because the attack vector is way too large. You can do anything that you can do for me as a user. And we're trying to improve that on all ends. It starts, for example, with secret scanning here. It's up to the secret partner to decide if they want to revoke it or not. Sometimes what you see, if you do that in a private repository, they say, well, the risk is a little bit less because only people with authentication can log in. They will give you an alert and then probably say, it's fine in there right now, you need to fix it. But be aware, it's not overriding it with an empty value and now it's fixed. It is stored forever in your Git repository, in your Git history. So if you want to do that, then you also need to scrub your history from that token. So it's even better, what we always say is just assume that it has been breached, rotate it, and then try to clean up afterwards anyway. But that is a decision that the secret partner can make if they immediately start revoking it for you. Currently, there's no way to rotate it automatically, for example. Don't know that there's a secret partner who does that. Currently, this is also a rather opaque process because no vendor is telling what they're actually doing to verify those things. So you learn about that by getting an email saying this is our token. Then you know at least that the vendor is handling that setup. But there's a documentation page that states all the vendors that are there and which type of tokens that they do. On Azure, for example, they scan for SQL connection strings. Super helpful. And I've blocked production a couple of times by doing that accidentally for a demo. So that's very cool. What they announced yesterday or the day before is that if you are a paid customer, they are now even doing it on this end. Where they say before we receive it and store it on our end in the GitHub repository, so probably a public repository, for example, we check and we have such a high confidence level for some of these secrets that we say, we stop it there. We reject your push with a log message saying, hey, there's a token in here. You can still override and still push through if you want to. But they say, we stop it already here. That's one of the newer paid features, but they're trying to improve that for all of us. It runs after a push event, but that's newer functionality that they released 2 days ago. It's very helpful that they're so active and you need to update your slides every week. They now also have it on the roadmap that they also want to do that in issues and pull requests. So not only when somebody does a git push, but also by preventing us from leaking it out in GitHub issues, for example. Apparently there are people copy and pasting tokens over in GitHub issues saying, hey, this should be this value. Blows my mind from a security perspective, but we try to educate everybody on this to improve that. As I said, it scans the entire history of the repository as well. So if you enable that, it will go through the entire history because that's what malicious attackers do as well. It's a Git database of a Git repository, so everything is there as well. I already explained, if it's an actionable secret, there's a high probability of that it will be revoked. And I've got one of my training examples to show you how that works inside of GitHub. It starts with a repository. In here, there is some source code, and there's probably a commit from a couple of years ago that had a token in there. If you go into settings and then security and analysis, you can enable all these features. Secret scanning. This is a private repository. That means that I can still disable it. On a public repository, it's always enabled, and you cannot even disable this. Trying to educate everybody. And since I've got the paid feature enabled on this training exercise, I can also enable those push protections. But that's a paid feature for now. After you've enabled that, or it's enabled on your public repository, it will automatically start scanning, and it scans your entire history. And if you go to the security tab and you're logged in, so it knows that you can see that information. So this is hidden from anybody else. Even if it's a public repository, this is only visible for the repository admins. So you need to have admin access because this is a security thing, of course. There you can switch between Dependabot alerts, code scanning alerts, and secret scanning alerts. And in here, I've got a commit from a colleague saying, hey, there's an Azure storage account key in here. So this is an S3 bucket on the Azure side. Somebody dropped the entire account key in a commit somewhere 3 years ago. So we found this because we're scanning the entire history. This one has been revoked since then. But GitHub at least tells us, hey, this one is compromised. We found this. We have high confidence that this is one of those types of access keys. In this case, it's the first one that it found. You should probably do something with this. You have that full traceability again to the commit where it came from. And even the user who said that they committed it, depending if they're using GPG key, for example. And then you can even indicate saying, hey, this one is a false positive, or I say this is used in a test. Or even better, we've already revoked it. So you can have that information as well. Super helpful for somebody in your company that is a CISO. Saying, hey, we have a breach, but it has already been revoked. You get that information back as well. This is enabled on all your public repositories already. Probably you didn't even know about that it was there. Yes. So that was secret scanning. Next up, CodeQL, another security feature that is available in GitHub repositories. And CodeQL comes, the name says Code Query Language. It comes from an acquisition that they did 2.5 years ago from SAML. And those people have created a database on top of your source code. The database can be created, in this case coming from a GitHub action here. where there's a specific action that will start creating the database. And while you then build up your application, this fires off and listens in to the build process. It learns all the traversal paths through your code. So method A is calling method B, is calling method C. It's injecting these parameters, they're transforming that parameter to that specific thing, and learning from all of those steps in your code. That's why they create a database, and when you have a database, you can create queries against it. Running those queries comes from another GitHub Actions step. You can run this in a container, but it's available for GitHub Actions as actions. And there it will run open source queries against that database that you have. So CodeQL learns all the steps that you make in your application. And there's a whole security community busy with creating those queries. How can we find things? For example, attacks that we've seen in the past, like SolariGate, where somebody's injecting something inside of your build pipeline. We can describe the patterns that are in there and match that, create a query for that you can now run on side of your database of your source code. So it's really cool that it is there available, and it's available for free on public repositories, so you can start using it out of the box. It has CLI support, so you can run things locally as well. If you try to do things locally, so you can bring that all the way left in the shift left methodology on your developer box if you want to. CLI is mostly there for security researchers who are creating those queries, because the database is already there. I'll show some examples of those open source queries, and currently we have support for these 7 languages. Ruby was recently added there. And those things already work. They can create that database, do the whole traversal in there, and then you can run those queries on top of that. Yeah, sure.
From what I know from SolariGate, they managed to not affect the source code, but put their malicious code directly into the DLLs that were generated. So I like you could have picked it up using
There is a pattern, yeah, we need to look it up, that they created that it detected the injection. Because if you have your source code, your pipeline as source code, that is then also an attack vector. So with SolariGate, they injected some DLLs into the artifact that you eventually deployed into your customer side or your cloud environment. And it did all sorts of cool ways to detect that if they were being detected by a tool, for example. If they saw certain tools running on the build machine, they said, well, let's stop our malicious activity. And still they got in the pipeline where they injected DLLs into the artifact. And that way they compromised 3,500 customers of the initial company who had created the software. I've got some examples of the query language up next. If GitHub is still working. This is a fork of the Tailwind Traders website. I was going for the indication there. You can go into settings or into actions. I'll both do the same thing now. You can go into actions. Who here uses GitHub Actions to create their build pipelines already? Show of hands, just a couple of people. With GitHub Actions, we have a generic workflow engine. So we can create CI/CD pipelines, but we can do way more things. I can even act when somebody creates an issue inside of my repository and do things there. I can act when somebody pushes code into the repository and start a CI pipeline, for example. I can do lots of cool things with GitHub Actions. So see this as a CI/CD system. It's text-based, it's stored inside of your repository, and from there you can start executing things. If you say, I want to create a new workflow, they have lots of open source templates that are in here, and under security there's a CodeQL analysis template that you can include. You can also include security scans from other vendors. So things like Codacity, indeed, DevSkim, this comes from the Azure DevOps side of things. There are examples for that as well, and you can even search for more. And if you say, configure me the CodeQL analysis, it will create a new workflow for you. It's always stored in the .github/workflows folder. And this has those steps available. In this case, we're running this when somebody pushes into the main branch, when somebody creates a pull request into the main branch, but also on a schedule. Because the queries that we run are open source and continuously maintained. So scanning it now once can tell you something now, but next week there might be more queries. So we also want to run this on a cron schedule. In this case, we're following a matrix here. It detected that we have C# code for the backend in this repository and JavaScript code in the as the front end here. It will check out the code. because this is running as static code analysis. It runs on your code base itself, so it needs the code as well. And then the init step will start the initialization of the database. We then try to build the application in this workflow. If it doesn't work, you can always include your own build steps. If you have a login for your custom artifact store, for example, you can include that as well. And then we start analyzing that. And analyzing it is running all those queries on top of the database that we just created. Those queries, I'll show that a bit later. What it then can do is run that query, and if it has results, you get a code scanning alert, only available for the admins of the repository or the ones with a security role. And in this case, we found one thing. Apparently here we are logging sensitive information in clear text. I think that is very sensible why that is a pattern that you should not do, of course, in your application. And you can dive deeper into that. We give it a severity level, similar to what we've seen with Dependabot with security vulnerabilities. And then here it says, in the provision composer JavaScript file, we apparently logging out a profile into the console log. And from the common weaknesses enumeration database, you can learn from Mitra why you shouldn't do that. I think why you shouldn't do that is clear. It is user information. And you can then start learning more about, for example, which query this came from. Go back to the CodeQL database with all the queries that they have and learn from that as well. And you can even view the code for that query. I'll do that next. Us as developers, we get an indication. If you've used SonarQube before, for example, you know those as well. You get an example of this is a way that you should not be doing this, but also an example of this is a way that you could be doing this in a better way. And we think that is something that you should do. In this case, the example shows you should not clear text, log the password, but at least encrypt it before you store it in a cookie, for example. Valid information for us as developers to know, so we can learn from that. It tells us which branches were affected in here, so you can run scans on each and every branch, on each and every pull request. This runs on GitHub Actions, and you pay for GitHub Action minutes, but if you have a public repository, that's included. And it gives you a little bit more of that insight. You can still say, I want to dismiss this, similar to what we've seen with vulnerability alerts. Saying, hey, this is okay in this case, and you can get that back in that single pane of glass in an overview. One of the cooler things is it tells us also where this sensitive data came from. It starts with a profile, but I'm not sure which sensitive data is used there. Already gives an indication. Apparently we're storing an app password in there. That's also called, in this application, a Microsoft app password. So we have 4 different entry points of data that go all into that profile. And in the end, that is being logged out into the console. And anybody who has access to your log files can then read that information. Nice thing of GitHub Actions is, if you use that in a public repository, then anybody who is logged into github.com can see the execution logs of your GitHub Actions workflow. So all the more important why this is an issue. What they also do is give you that show paths button, and this is the real interesting part. I said before, they generate a graph database of all the traversal methods through your code. And this is what they have found with that query. Initially, we're sending in the app password from the argument list when we start up this application. This could be a password to go out into a third-party API, for example. We do that a couple of times, so this is another hit for the app password and another hit for the app password. Here we're sending that into a method and already converting it to something. You can then dive into each file and learn more about that. And then here you can see from the app password, we transform that into a new object, a create result object. This all came information from the database that it created from our own code. Then in the next example, and this is still the create result, because that happened a couple of times, we all of a sudden from the create result, we start creating a new object into a settings thing. That settings thing gets created from the create result into a profile. So we're now already in step 8. I think in step 10, we then say, stringify the profile, and just input it into our console log. And this is where the vulnerability happens. So all those places before were places where we could have sanitized this thing and made sure that we annotated it with something that tells the console log to never ever spool out that information, for example. So since that we have that entire, it's called a graph database, it points to each method that we execute, we can learn of why these things happen and how those things come to be. So super interesting stuff that you have available as well. I already have that open. If you go to CodeQL, that's a public repository. Oh. And in here you can see per language, in this case JavaScript, query languages, and on the source they have different categories. We came from the security category, where there are different categories in here. There are lots of queries that already have been created. And if you dive deeper into one of those, this one is for the common weakness enumeration 312. You should not log in clear text. This is the query that they create to get those things. And this is a complicated query, so if you really want to dive into it, this is all open source, you can learn this. But this is really a SQL statement. Import the language that we need. We have a clear text login query there. We have some predicates that we do. In the end, you do a from statement with a where statement, and you do things there. This is so complex that this blows my mind as well, so be warned. If you have an inclination, you can create these things yourself and become a security advisory contributor there. You can contribute those queries back. There's a whole community implementing these things. This is the query that came from the link in the warning. There's also the content for the help file here, the example of the things you should be doing and should not be doing. So you have that, all of that stuff is all information available as open source in the repository. And indeed, in the way that eventually works, it's nice that the network is slow enough that it doesn't do this. What CodeQL in the end does is spit out a SARIF file. And SARIF stands for Static Analysis Results Interchange Format. This is now a de facto standard, it's becoming. It's even an Oasis standard now. And more vendors are using that specific file to indicate all of these types of security warnings. And the nice thing is you can input these between vendors. So I can send in the SARIF file that CodeQL generates into SonarQube and let SonarQube as a seam do the same thing, give warnings to our users, and vice versa. So you're not tied to one specific system that generates these things. As long as it can spit out a SARIF file, then it's interchangeable and you can use it in multiple places. And it's now a whole community who's building on top of that. So very interesting stuff that I at least want to make you all aware of. These were my screenshots in case things didn't work. And that was the end of the things that I wanted to share. I hope you learned something new. You picked something up there. And if you have questions, I'm still here. You can chat me up. And if you have other things, then you can always find me online and ask me questions there. So thank you so much.